Hello everyone, my name is Sandra and I'm a computer science engineering student at Tengiz College of Engineering, Kerala. I'll be teaching you about the concept of modules in Python, how we can use them in our programs, and also I'll be teaching about the concept of packages and some practical relevance of modules. So first of all, what is a module? Python organizes code into units called modules. So basically, modules are actually files containing Python statements and definitions. Now, module can define functions, classes, or variables, and it can even include runnable code. Now, why do we need modules? We can group related code into a module, and it makes the code easier to understand and use. For example, if I have two or three functions that does almost similar functionalities, then I can combine them together into a module with a common name, so that it'll be easier for me to handle it. I'll be showing you with some examples in the coming slides. Python has numerous built-in modules, for example, math, datetime, etc. You can also write your own modules. In fact, every Python file is its own module. Now let's talk about how we can use modules. So we can use modules by importing them. So when you import, for example, a function, then you're essentially using a module. A module is a Python file with a .py extension. So if you want to make your own module, you have to save it as filename.py. Now let's see the syntax for importing a module. We can import a module by using this syntax. That is import space the module name. And then we can access the contents of that module with this syntax. That is the module name dot the entity name. So as I said earlier, if I have two or three functions in my module that has almost similar functionalities, then I can use module name dot that function's name to call it and use it. Now let me show you an example of a module that I'm making. Now my module's name is calc.py and the function for now it does is adding. So it has a function that adds two variables x and y and it returns x plus y. So now I'm making another Python file called result.py and I'll be importing this module and using it over here. So to import it, I use import space the module name that is calc. Now I want to use it. Let's say I want to add the numbers 2 and 3. So I type this command print calc dot add, which is the entity name, and now the parameters 2, 3. And now let's run it. So you see the answer is 5. So that was a basic example of using a module. Now we can also change a module's name and use an alias name by using the modifier as. For example, if my module's actual name was user underscore function and I want to change the name to my code, then I use this command import user underscore function as my code. And then when I use the module later in the program, I can just call it with my code. For example, if I want to print a function, my function, which is a part of the module user function, user underscore function, then I can use the command print my code dot my function 3, and it does the same as when you use user underscore function. Let me show you that with the previous example that we were talking about. Now I want to change the name of this module, that is use an alias name. So I'm going to give it import calc as A. So A is the new name that I'm going to be using in my program. So I'll just change this to A dot add 2 comma 3, and then I'm going to run it. And there you have it. You get the same result. Now let's talk about another important statement for using modules, and that is the from import statement. Python's from import statement lets you import specific attributes from a module into the current namespace. This is the syntax. So you write from space the module name and then import space the specific attributes that you want to use. For example, from fib, I import the module Fibonacci. Now, what's the use of this? So when you use the from import statement, when you use the attribute in the module in the program, then you don't have to use module name dot the entity name anymore. You could just directly use those attributes. Now let me show you that with an example. Now over here, math is a built-in module, and some of the entities in math are pi, sqrt for square root, cos h, tan h, etc. Now I want to use the function pi. That is, I want to print the value of pi. So what I normally do is this: print is math.pi. And when I run this, I get the answer 3.14, which is the value of pi. Now if I had given this without the math dot part, let me run this, then it would show an error that pi is not defined. Now that's where I use the from import statement. So now I type from math import pi. So what we're basically doing here is we're importing just the pi entity from the module math. So now let's see what happens. Now when you run this, you get the pi value. So now you understand. Now we don't have to write math.pi anymore. We could just directly write pi. Now, another statement similar to from import is the from import star. It's possible to import all the names of from a module into the current namespace by using the import statement from module name import star. So what it does is it imports all the attributes from that module so that we can use it without having to write module name dot attribute name. So like in the previous example, if I want to import all the attributes in the math module, then I would just write from math import star, and then it'll import all the attributes of math module. Now let's talk about an important function while using modules, and that is the dir function. The dir function is a built-in function that returns a sorted list of strings containing the names defined by a module. Now, the list contains the name of all the modules, variables, and functions that are defined in that module. Now, let me make that clear to you with an example. Now, let's consider the previous module we took, that is the math module. Import. So, first we import it using import math. Now, I want to see all the variables and functions and attributes in that module. So I use the dir function. This is how I use it. Now I want to display all those variables and things on screen. So I use print dir inside that the module name math. Now I'm going to run it. And here it shows all the variables, the attributes, and everything in it. It's a long list. Now we'll talk about another built-in module called the datetime module. In Python, the datetime module is a relatively complex module that simplifies operations on dates and time. In Python, date and time are not a data type of its own, but this module, that is the datetime module, can be imported to work with the date as well as time. What it does is it supplies classes to work with date and time. Now, let me show you how this works. So, this is an example of the datetime module. I have given two statements over here: print datetime dot date dot today. So, this statement prints today's date. The next one, print datetime dot datetime dot now. This statement prints the date along with the time. Now let's run it and see what happens. See, for the first statement, we have the output as the date, today's date, and the next one, we have the date printed along with the time. So, have you ever thought what happens when you actually import a module? What is actually happening in the system? So, when you import a module, the Python interpreter searches for the module in the following sequence. First, it searches the current directory. The current directory is the folder where your current Python script is being run. Now, if the module isn't found there, Python searches each directory in the shell variable Python path. Now, Python path is basically an environment variable that is, it is stored in the computer memory, and it has a list of all the directories where your module could be found. Now, if that also fails, it searches, it checks for the default path. Now, the default path is completely installation dependent. That is, it depends on your system, whether it's Windows or Unix, whatever. There's a default path. So, this module search path is stored in the system module sys as the sys.path variable. And this sys.path variable is the one that contains all the locations. That is the current directory, the Python path variable, the installation dependent default path, etc. Now I'll show you how to run that code. So I'll show you how to print the directories. So first we need to import the sys module. And now I want to display all the paths. So I print sys.path variable which I've told that it contains all the directories, Python path, etc. So I'm going to run this. So as you can see, this is the list of all the locations of the directories, etc. Now let's talk about the concept of packages in Python. Python modules can be categorized into packages by placing them within folders, and these folders are called the packages. So we can think of packages like the folders in our computer. Now we have lots of files in our system, right? We have music files, we have videos, we have pictures, games, etc. Now, we never mix all of them together, right? We never keep all of them in the same file. We have separate folders for each category. So, same like that, these packages also behave like these folders. So, when our application program grows larger in size with a lot of modules, we place similar modules in one package and different modules in different packages. Now, this is what makes the project easy to manage and conceptually clear. And for in order for the directory to become a package, that directory must contain a file named underscore underscore init underscore underscore dot py. So the system, that is the Python interpreter, recognizes the folder to be a package only if it has the file named this. Now this is a representation of a package. Now our main package is game. So as I said, it has a file called underscore underscore init underscore underscore dot py, and the package has sub packages. One is sound, one is image, and one is level. Now each sub packages also has the underscore underscore init underscore underscore dot py file, and that is in order for the interpreter to understand that sound is a sub package. Now inside the sub packages we have lots of modules. For example, in sound we have load, play, pause. In image we have open, change, close, etc. So now let's talk about the practical relevance of using modules. We use modules to break down large programs into small, manageable, and organized files. And modules provide reusability of code. We can have different kinds of modules and we could use it in many of our programs. We can define our most used functions in a module and import it instead of copying the definitions into different programs. For example, if I have a function for adding and I use that in many or most of my Python scripts. So instead of writing that function again and again in each program, I could just make that into a module and use it whenever I require it. And about packages, we have packages to organize these modules of similar functionality. So that was it about modules and how to use them, and also about packages. Thank you for listening.